Yeah, so the last one we finished up with was this single quote swap after equals. And okay, so string parsing. The next one, the next function / business rule we have here is, and again, the last one we did was single quote swap after equals. And these are going to be a whole bunch of swap stuff. So export const swap forward / to / equals function. And once we write the first one, then the rest of forward / to / input data, input metadata. And once we write the first one, then the rest of them are just going to be copy paste and little edits. That function swap forward / and description swaps all forward / characters in a string for / characters. Okay. And all string, input data string that might contain some forward slashes. Input metadata not used for this business rule. And return is the same as the input string, just all forward / characters for / characters. And author and date 02/02/22/22. Love the date. Okay. And then we can copy paste from is string. I think this one is a nice short one. So contents of that function is string, and paste it in here and change the name. Return data. We can just make it an empty string. Everything inside the if can come out. Return data equals array parsing dot replace with character input data, and then we're going to pass it this regular expression again, which looks like, oops, I messed that up. Okay, it looks like that. G, comma, double /. Yeah. And now we can just copy the entire thing, including the header, and let's just paste it once. We don't want to paste it. I mean, I know we're going to need like 4 of these, but we don't want to go gung ho crazy because it's very easy to forget stuff. So we want to be very meticulous about how we go back over these. So the next one, now that we've copy pasted, let's make sure we're editing the one we pasted and not the one above it. Okay. All right, and then so the name changed to swap. So instead of forward, it's / to /.
Okay. Okay.
And then we'll just go line by line, very meticulous. Swaps all / oops, I made a typo. Let me fix that. I'm going to fix it in my other one too. It's not slash. Okay, there we go.
Backslash.
/ characters for / characters. And then the input data string that might contain some backslashes. Okay, and then the return should say same as the input string, just all swap for forward / characters. Then the name has to change here. The actual definition of the function itself. / characters to forward. Yeah, you can copy paste. Yep. Change the name here on the name, function name. Only other thing we need to change is right here. Instead of doing that, we just need to reverse that to And then this changes from a double backslash to a single slash. Followed along very meticulously with that one. You should have it. So now let's copy paste the one we just edited, the new backslash to forward slash, including the header. Let's copy it again. So the very last one. Select everything there, and we'll copy paste it again. Paste it. Okay, I'm working on the last one, not the one that was above that. Okay, and now we're going to change it again. This time it's swap double forward slash to single slash.
Okay.
Swap double forward slash to single. Okay, we get all the names. Swap double forward slash to single forward slash. Okay, and the description should be swaps all double forward for not for characters, for single slash characters. Oops, I got an S on there. I don't want that. I'm going to get rid of that. Contains some, might contain some double forward. Same as the input string. All, this should set, instead of back, all double slash characters swapped for single forward slash characters. I think everything else is fine except for the regular expression. So that should be the only thing left. And for this one, we just need to go, and it's really weird, backslash forward slash dash forward slash. We got two more functions to implement, so we're just going to copy paste this entire thing again. This time, did you get the last one finished up? I think you did. Go to the bottom, make sure it's the very last one. Okay, we'll copy paste that, including the header again. This one we change double, instead of double forward, it's double back. Slash to single.
It's still a swap? Yeah.
Yeah. Single backslash. Okay, swaps all double back slash characters for single back slash characters. String that might contain some double back slash characters, backslashes, okay, and return the input string just all double back slash characters swapped for single.
You said just all double backslash characters?
Yeah, the same as just all double backslash characters swapped for single backslash characters. I think we got the name, swap double backslash to single backslash. Okay, so that's the name. I'll put that down here for this and this. The only thing we have left is this thing right here needs to change to be 1, 2, 3, 4 backslashes. And this changes to 2 backslashes. We've got one more function, and it's technically a business rule, but it's not really one that we export. It's a common thing we use. All right, we've got a separation here because everything we've been developing up until this point has been functions that we actually export. So export const. This one, the next one is we're not going to export it. It's an internal function. So I'm just going to copy paste this little thing here that says internal function. You can just make a block like that for yourself. And there's only one of these. Start it off, it's going to say const replace character at index of string equals function original string and replacement. Okay, and I have a header like we always do because that's got to be there. at function replace character at index of string at description replaces the character at a specified index with another character. Okay. This is a string. Original string is a string. The index is an integer. And the replacement is a string. And the return is the string where the replacement should be made. And the index okay. The index is the index of the character where the replacement should be made. Replacement itself is the character or string that should be inserted at specified index. And then we have the return, which is the string after the replacement has been made. And then author and date. And a reference, curly brace at link. We do need to copy paste the, I guess the contents of the entire function. The one above is fine. Paste it in there. Change the name. Yep, the original string needs to come down here to this one. Index move down to this one. And we could, oops, this needs to be index, and this needs to be original string. Copy paste one of these and make another one because we got 3 parameters. Replacement down. Inside of the if, come out. So now instead of input data, because we don't have an input data here, we're going to say if original string not equal to an empty string and index greater than or equal to 0 and replacement not equal to an empty string, then return data equal original string dot substring 0 comma index plus replacement plus original string dot substring index plus replacement dot length. Okay, so that's it. That's the end of that one. The only thing we do next is we can close all of these because we're done now with our rules at this point. The next thing is the configurator. So we have to go back to the config, and I should add that we're going to change. Right now in the configurator we have a get set configuration and get configuration setting, and both of these are flat. They're just like right here. It's a one level deep. Deconfiguration, and then it's configuration name. And so you can imagine, like if I go to my configuration file, the framework, right now I've got, you know, how many of these? I've got 7 of them. Okay, so you can imagine if we start adding a whole lot of configurations for every single file, you've got debug files, you're going to have all your files, you're going to have debug functions with every single function in your entire code base, and it's going to grow. If you could imagine every single function, how many we did for string parsing, we have like, what, 18 functions? Mm-hmm. You can see them right here, swap double / swap double /, but then there's like a whole bunch of other ones, like all the way down, and you could imagine how much this is going to scale. Now, this is just for the generic version. Imagine we could add you could add an additional 12 different attributes for every single one of these. So 12 for this one, 12 for that one, 12 for that one, 12 for this one, 12 for that one. All the way down line on number 240, 12 for that one, 12 for that one, 12 for that one. So now we're talking like, 8 to 10,000 configuration properties. Okay, so are you going to be able to manage that? Because I know I can't.
Right.
And so that's where we're starting to think about, we make a hierarchical system with multiple files and multiple folders where we can organize these massive configuration data sets that we're going to need. That's what we're looking at. How can we make this so that when it loads multiple files and multiple folders, that it maintains the hierarchy of that folder structure and knows where to get what it is that it needs to get. So that's what we're going to be looking at next. And it's really getting into, because this is a data structure, it's a JSON data structure, data object, which is, JSON is these curly brackets. So yeah, it's that JSON object. We're going to dive deep into how we can modify this data structure to work with that hierarchy and program it, right? It's got to be it's got to work. It's got to be fully automated. And it's got to work for getting, it's got to work for setting, and then there's other stuff we're going to need. Like we're going to need to be able to get the namespace. And there's a number of other functions, like getting the parent, the namespace of the parent object. Because maybe you don't want to look at the child, you want to look at the parent and navigate to all of its attributes.
Right.
So there's all kinds of additional stuff we're going to need, a few extra additional functions, and I've got it, it works, I've got the code, and we'll just walk through how it's done. And when it's done, then you'll see, oh man, you can really do some cool stuff with data structures and data objects and build out hierarchies of trees, and it's very powerful. It'll help us to scale a lot. And it'll help you with your I mean, the best I could say it is, how you intellectualize the code, right?
Right.
So, it's all about helping you grow, to mentor you, and help you to get some career growth, and how you understand the code and how you can write code and understand how it's been written. So that's what this is going to be. We're going to look into building an advanced configuration system using an advanced programmed data structure. And this is one piece of the programmed data structure, because there's other data structures. Right now, if we go to our structures folder, it has just the data, and it's just the data, right? There's nothing really else there.
Right.
But we're gonna, later on, actually, I think it happens. It's in the branch I'm working on now, which is training branch 8. What we'll probably end up doing is, once we get past training branch 5 or 6, we'll probably call it quits. Take you to the real repo and just walk you through some of the stuff that has been done since that training branch 5 or 6. So you'll see a little bit more about the commands. You'll see about, because I don't know if you know, like you when you go to print a document, right? You submit your document to a print queue, and other people could submit to the print queue, and you could submit tons of jobs to the print queue, and then the print queue just prints whatever's at the top first.
Right.
It's a queue, and we can actually implement a data structure, a queue data structure, on this data object. And so that's something else we're going to need to do, and we use that because we need the queue to manage our command queue. So you can submit commands to the command queue, and then they'll execute just like as if they was executing print jobs.
Oh, cool. Okay.
So very, very powerful tools. Whatever goes on the command queue is going to be executed in sequential queue order.
Right.
Another data structure that's extremely useful is a stack. Like you push stuff on the stack and you pop it off. A stack is useful for programming languages. Like when I'm executing from the warden, and then the warden calls the rule broker, or it calls the chief configuration, and the chief configuration calls the chief data, and the chief data calls the data broker, and the data broker calls file operations. So every time I make a call, warden calls chief configuration calls chief data. So each time I'm making a call, it's pushing up the call structure to a stack. It's called a call stack. And when you throw an error somewhere in your application, it's going to print that call stack. so you can get the call stack, and you'll see it when you get an error message, right? You'll see that list of stuff that errored out. What call led to what call led to what call. That's a stack, right? And as you return from your function, it pops it back off the stack, right? So it's automatically doing it as you're calling functions and returning from functions. And we're going to have a lexicographical analyzer. The command engine requires us to have a lexicographical analyzer to analyze commands and command arguments. And that's the beginning of a scripting language. You can't have a scripting language without a lexicographical analyzer. So all of those things play together. And the stack that we're going to be build can be custom defined. So you can go and write your own. You can define your own stack and then just put stuff on your own stack as to whatever you need. So very, very powerful, useful stuff. And we'll learn a little bit more about that further along. We have stuff to do before we get there. But it gives you a taste of what's coming down the pipe.
Yes, sounds really interesting. So.
Yep. All right, I'll let you get going. I know we're running a little late, so
all right, man.
Good evening. We'll see you tomorrow.
Thank you.